Hey guys, today we're going to be measuring the current draw of an LED. Now, you may be wondering why I've got this really elaborate setup here in order to do that, because, this should be simple. But what I want to try to do is actually bring up one of these LEDs to about 10 volts or so, and just see how much current it's drawing at 10 volts. And the reason why I want to be able to do that is because I've been messing around with these Joule Thief circuits, and if you've watched my video probing a Joule Thief with an oscilloscope, I'll link to that, put a card like over here or something like that. But anyway, those Joule Thief circuits actually put in a really high voltage spike in order to get the LED to turn on. And one of them that I tested, I actually saw about a 7-volt spike voltage. So I want to see how much current this LED actually takes at that kind of voltage. Alright, so I'll go ahead and explain the setup here. First off, I've got a 555 timer circuit over here. This is set up to give me a pulse of 250 microseconds, which hopefully won't damage the LED too badly, or at least not too quickly. Then here I've got our power handling circuitry. So right now I've got it set down at like 2 volts. And I've done a little bit of testing with this just to make sure that it'll work. But this is an IRF 5030 or something like that. It's just a MOSFET. Anyway, and the 555 circuit's powered off of 4 AA's that are in here. And then for the actual circuit that's powering the LED, I've got a 1 ohm resistor as a current shunt in there, with the 2 grounds on the scope probe actually hooked into the positive of the power supply circuitry that's for the MOSFET and the LED. And then channel 2 on the scope is hooked up to the resistor on the other side of the resistor, so I can measure the voltage drop across the resistor, which would be the current. And then channel 1 is just hooked up so I can measure the voltage of the LED. Now, as for the actual power supply circuit itself, this is one of these little buck regulators here, switch mode, and then this is a laptop power supply. This puts out 19 volts. I should be able to put out at least 16 through this. And I've also got a big 4700 microfarad capacitor here to hopefully help with the pulses of current that this circuit will take. And then this meter is measuring the voltage of the power supply. This tablet is over here. This is where I'm going to record all the data, and I hooked up a keyboard to it just because I can make this a little bit easier. But anyway, also one thing to note about this: when you're measuring things with the oscilloscope, you have to take into account that the voltage that you're measuring over here also includes the voltage that's being dropped across the resistor. So inside this little spreadsheet here, I've set up the measured voltage with the oscilloscope, and then the current draw, or the voltage that's across that resistor, which is a 1 ohm resistor, so the amount of voltage that you draw is the same as the amount of current that's going through the resistor. So basically I'm just subtracting the current from the measured voltage to get me the actual voltage that's going across the LED. So that's how that's working. I'll go ahead and show you what I've got on the scope real quick, and then I'm going to go ahead and test this for a while. I'll bump the voltage up by like half a volt at a time until I get up to 10 volts, and then we'll make a graph with that and I'll show you the results. And this is what it looks like on the scope here. You'll notice everything is negative, and that's just because of the way that I have it set up with the ground on the positive side, but it works just the same way. And then I'm just measuring V base on both channels there. That gets me the measurement of the amount of current that there is. Top channel's voltage, bottom channel's current. This was the test at 2 volts or so. Actually, you can see it there, 2.02 volts is what it's set for. I'm not entirely sure why it trails off so slowly at that end, but I mean, it seems like it works well enough. For a simple little test like that, you see it only pulled like 5 milliamps off of that. And I think this is just some random LED that I picked, but I stuck it in one of my component testers, and it showed a forward voltage of 2.02 volts or something. I'm sorry, it's like 1.98 to 2 volts or something, or along those lines. It wasn't all that high, but anyway, I'll go ahead and keep upping the voltage and recording all the measurements, and I'll get back to you with a graph here in a minute. Before I do that, I'll give you a little bit of a closer look at the circuit and how I'm triggering this. I've just got this one piece of wire. If I pull this down to ground, you should see the LEDs flash there. This LED is just in here as an indicator. This other one's the one that's actually being tested. So anyhow, that's the circuit setup. Like I said, it's just a 555 monostable circuit, I believe. But anyway, I'm going to get to work testing on this, and it should be simple enough.
Alright, so let's have a look at the data we have here. I've got two graphs, and I'll explain that in a second. And I also I had to move this data over into Excel Online because A, I don't have the full version of Microsoft Office on my computer, and B, apparently Google Sheets doesn't have the ability just to make a simple graph like this, plotting XY coordinates with a line. So I could have done like a scatter plot on Google Sheets, but I didn't really want to. But anyway, I just copy pasted the voltage and current data off of my Google Sheets, and this is I only got up to about 9.6 volts on the LED. That's the highest I could get it to push with my setup. I kind of think it's because the MOSFET wasn't getting turned fully on, so I was losing a lot of voltage through the MOSFET. But that doesn't matter because we weren't needing to know the voltage measurement across the MOSFET because we were measuring the voltage across the LED. So, alright, and by the way, this is the voltage where I took the measured voltage from the oscilloscope and then I subtracted the current so that the voltage drop across the current shunt resistor wasn't a factor in the measurements here. So anyway, this is the actual voltage across the LED, and then that's the current that the LED is taking. And the LED actually still works just fine. Still draws current and still lights up. So anyway, this is what the graph came out to look like. And this is the graph of the entire data set. This graph over here is only of this much data. Because I thought this looked kind of weird because it's just a linear increase from about the forward voltage up to as high as I could get it to go, which is about 9.6 volts. And I found that kind of surprising because usually when you think LED current graph, the voltage or the current just kind of goes like this. It's more straight up than that. And that's kind of what this one looks like, sort of, but that still kind of goes up slow. I did find another one of these. Just looking through the internet here, Google Images. So anyway, that's a blue LED. I have a green LED, so pretty much the same deal there. And this graph looks just about the same as mine, so I guess that's just how it is. And then this is what a red LED looks like. That one shoots straight up, like what I expect, but that might just be because the forward voltage is lower. I might have to try this again in another video with a red LED. But anyway, so this is the graph that I was expecting to get, and then this is the graph that I actually got. So anyway, that's what the current graph for a green 5mm LED looks like, all the way up to about 9.6 volts and 400 milliamps. I honestly did expect it to take a lot more current up toward the 10 volt mark. I was kind of expecting to get up to an amp. That's why I had that big capacitor and things like that. But then again, I've never tested something like this before. So anyway, I think that it's kind of an interesting result here. And there's kind of some variation in it, which is alright, but probably just due to the test setup. Alright, just a little bit of a disclaimer here. I should note, this probably isn't the most accurate way to measure the voltage and current. For one, that 1 ohm resistor that I'm using as a current shunt is just a standard 5% one, so the voltages or the current might not be 100% accurate. Also, an oscilloscope isn't really the best measurement device to measure voltage. And also just the sheer act of only pulsing the currents onto the LED is kind of maybe not the best practice because it doesn't give it any time to warm up or anything like that. So I'd imagine if you left it at that 9.6 volts for any length of time, it would eventually either go open circuit or short out. So anyway, it's good enough for a test like this to draw a graph, and you can see what I got. But anyhow, hopefully someone found this interesting. I might redo this video and do it with a red LED as well. But anyway, that's what a current graph for a 5mm green LED looks like up to 9.6 volts. So that's it for now, guys. Bye.